All right, guys, so for this first video in Chapter 12, we're going to be starting our trig stuff. Trigonometry is basically just the relationships between angles and sides of a right triangle. So that's what we're going to be starting with, and I know a lot of this is going to look familiar from geometry. So let me just set you guys up with kind of the notation and everything that we are going to be using. All right, so here if we set up a little right triangle like this, we know that this right here is our right angle. We use capital A, B, and C to refer to our angles, and we always use C as our right angle. So let's call this one A, and we'll call this one B. All right, so then we have in reference, let's say we want to use this as our angle. So we use theta, which is a Greek letter. And so in reference to theta, we have these three measurements. We have the hypotenuse, and that's what's always opposite this right triangle. So this is our hypotenuse. And I'm hoping you guys recognize that word. So the hypotenuse is always opposite the right angle. And then in reference to theta, we have two different sides. We have the leg that's opposite theta. And so since this is theta, the leg opposite theta would be this one. So we have opposite, and then the leg that's adjacent to theta. So that's the one that's touching the angle but isn't the hypotenuse. All right, so we consider this one to be our adjacent. So we have the hypotenuse, the opposite, and the adjacent, and we use those three measurements to talk about our different trig functions. So we have the three that you guys are used to. So we've got sine, cosine, and tangent. So if we say sine of theta, the sine is the ratio of the opposite side divided by the hypotenuse. All right, so we've got the opposite side divided by the hypotenuse, that is sine. We also have cosine of this angle theta. Cosine is the ratio of the adjacent side divided by the hypotenuse. And then we have tangent. And tangent is the adjacent side over the opposite side. All right, so I'm sure you guys have heard SOHCAHTOA. Oops, I'm sorry, SOHCAHTOA, we've got this mixed up. This is our opposite side over our adjacent side. Sorry about that. So we've got SOHCAHTOA, so you guys probably remember that from geometry. So then with those, we have these other three that you guys probably do not know. So we have these other three functions that are called cosecant, secant, and cotangent. So cosecant pairs with sine. It's the reciprocal of sine. So sine is opposite over hypotenuse. Well, cosecant is hypotenuse over opposite. And then with cosine, its reciprocal is called secant. And secant is just the reciprocal, so it is the hypotenuse divided by the adjacent. And then we have this last one, cotangent, and cotangent is the reciprocal of tangent. So sorry, that's the one I had in my head here. So that is adjacent divided by opposite. All right, so we've got a grand total of 6. There's the 3 that you guys are probably familiar with from geometry, and then we've got 3 new ones that are the reciprocal functions. So this we are going to do just a quick example of just finding the 6 trig functions. So we've got everything all set up here. So here's our angle theta. We have 3 sides that are marked on here. So you guys will have just kind of these introductory problems where all you're doing is just identifying what the 6 trig functions are. All right, so we've got sine. So here's theta. Sine is opposite over hypotenuse. So the opposite leg is 8 units long, and the hypotenuse is 17 units long. Think SOHCAHTOA. Cosine is the adjacent over the hypotenuse. That's 15 over 17. And tangent. Tangent is the TOA of SOHCAHTOA. So tangent is the opposite side divided by the adjacent sides. That would be 8 over 15. And then the other 3, remember, are just the reciprocals. So once you find these 3, if you know which ones they pair with, you can just flip them. So cosecant is the reciprocal of sine, so just flip to its reciprocal. So 8 over 17 flips to 17 over 8. And then secant is the reciprocal of cosine, so flip this fraction. We now have 17 over 15. And the 6th one is cotangent, which is the reciprocal of tangent, so just flip this one, and we have 15 over 8. All right, so we have the 3 that we know from SOHCAHTOA, and then you have the 3 that you can know from them being reciprocal. So let me write, just so we have it written down here, cosecant, secant, and cotangents are reciprocals of these 3 functions here. So the way that we define cosecant, we can write that it is 1 over sine, which is just a notation to write that it's the reciprocal of sine. And then same thing, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. All right, so if you know those relationships, you should be pretty comfortable with how all of them relate together. All right, so another type of example that we can do is something like number 2, where you know what the tangent is, and then you want to find the other 5. Okay, so the best way to do this, we call these triangle problems. You just kind of sketch out what the triangle would look like that matches with this scenario. So if we know that the tangent is 15/3, set yourself up with a little triangle. So we know this is the right triangle, that's C. Make this A, make this B. So if the tangent of A, so that's this angle right here, and we know the tangent is 5/3. So we know that tangent is opposite over adjacent. So that means the opposite side to angle A is 5. So that would be this one right here. So you can label this as 5. And then the adjacent side to A would be 3. So this would be the adjacent side, and we can label that as 3. So we've got 2 out of our 3 sides. So the way that we find the last one is by doing the Pythagorean Theorem. So I'm sure you guys remember that from geometry as well. The Pythagorean Theorem is a squared plus b squared equals c squared, and we use that to calculate any missing sides that we have. All right, so use the Pythagorean Theorem. And that's this missing side right here. This is c. So little c in a squared plus b squared equals c squared is always the hypotenuse. Okay, so little a is the one across from a, so that's 5 squared, plus, and little b is the one across from b, so that's 3 squared, and of course little c is across from c, that's the one we don't know. So we've got 5 squared is 25, plus 3 squared is 9, equals c squared. So 25 plus 9 is 34. So we've got this lovely square root value. In this case, we don't do plus or minus when we take a square root because we're talking about a side length, and side lengths are never going to be negative. So c is just the square root of 34. So you can mark that on there. That's the last piece that we just found. So we just figured out that this is the square root of 34. So now that we have all 3 of our sides, now we can put together sine, cosine, the other ones that we're missing. So we have tangent. So sine of A, here's A. So sine, remember, would be opposite over hypotenuse. So it would be 5 over the square root of 34. And then cosine of A would be the adjacent over the hypotenuse, so 3 over the square root of 34. Normally you would be rationalizing these. I'm not going to make you guys rationalize them. And then we've got the pairs, the reciprocals. So cosecant is the reciprocal, so just flip these, and we have root 34 over 5. Secant is the reciprocal of cosine, so that would be root 34 over 3. Just flip this one. And then our last one that we're missing is cotangent, and cotangent is the reciprocal of tangent. So instead of 5/3, it would be 3/5. So these would be the 5 that we're missing. So we came up with those by starting with a right triangle and then moving from there. All right, so next thing we've got here, these special triangles that come from like these nice, neat 30, 45 degree, 60 degree triangles. You guys probably did this in geometry as well, so this should all be familiar. So our 30, 45, and 60 degree triangles, these pop up all the time. So we want to make sure you guys are comfortable with these ratios. So 30, 60, 90 triangle, let me set something up for you. Let's say we have this big, I'm going to start out with what is an equilateral triangle. All right, an equilateral triangle is one where all 3 of the angles are the same and all 3 of the sides are the same. So we know that these would all be 60 degree angles. And then all the sides would be the same. So you can just call them like x, 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 you know, whatever you want to label them. So what we're going to do to create a 30, 60, 90 triangle is we're just going to chop this right in half. So if we chop it in half, this becomes a 90 degree angle. This is still 60. And if we chop this in half, this is now our 60 degree, or I'm sorry, our 30, 60, 90. So we're just kind of looking at this triangle right here when we create this 30, 60, 90. So we just care about this. And we're going to figure out what all of the measurements would be. All right, so let's say that this measurement right here, let's just call this x. We're going to take the short side and just label it x. All right, so what we know, originally in this triangle, these were all the same length. So if I cut this in half, this would be double that length. So this would now be a 2x. Okay, so if this is x, this is now 2x because this used to be the whole length and I chopped it in half. So if this used to be 2x, then that means that this is 2x. And so is this for this matter, but we're not labeling that other side. So now we want to find what this third side would be. So we can just do a little Pythagorean theorem. So we know that this is the hypotenuse right here. So we do a squared, which is the side that we're trying to find, plus x squared equals 2x squared. And we can simplify this all down. So we have a squared plus x squared. If we square this, we get 4x squared. And to get a by itself, I would subtract this. So I get a squared equals, this just ends up being a 3x squared, and I square root everything. So my last missing side is root 3 times x, because when I square root x squared, I just get x. So it ends up being root 3 times x, which I'm not used to seeing the root 3 out front, so let's just label it right here. So x times root 3. All right, so we've got these 3 measurements right here. So when we're talking about a 30, 60, 90 triangle, we can very easily remember what the sine, cosine, and tangent are. So let's say we want the sine, cosine, and tangent of the 30-degree. All right, so for referencing this angle up here, remember this angle is technically 30 degrees because I chopped this in half. So sine would be opposite over hypotenuse. So that would be x over 2x, and then the x's would just cancel. So x over 2x would just reduce down to 1/2. So the sine of 30 is always going to be 1/2 according to the special triangle. And then for cosine, I can do the same thing. If we look at this angle, we've got the adjacent over the hypotenuse. So this measurement over this measurement, and again, the x's would cancel. So I would end up with root 3 over 2. And then finally the tangent. The tangent would be the opposite over the adjacent. So the x's would cancel here, and I would just have 1 over root 3. All right, so that's my sine, cosine, and tangent for 30. I can also do the same for 60. So these are going to be values that eventually you guys are going to have memorized. For right now, though, we just want to have them written down. All right, so now if we use this as our reference angle, sine would be the opposite over hypotenuse, and the x's would cancel, so we'd have root 3 divided by 2. And then cosine, looking at this, would be the adjacent, which is this one, over the hypotenuse. So 1x over 2x reduces down to 1 over 2, and the x's cancel. And tangent, this time, would be opposite over adjacent, so the x's would cancel, and it would just be root 3 this time. So those values, like I said, eventually you're going to have these memorized, but for now, it's just something to make sure that we know so you can use them on your homework. And last thing we're going to do is the 45, 45, 90 triangle. So set up this nice little 45, 45, 90. So here's what we know about the 45, 45, 90. This is a right angle, of course. These are both 45-degree angles. So if they're both 45-degree angles, that means that their legs are the same. Okay, so what we do is we say, let's just label these both x. Whatever this is, we know that this is the exact same measurement right here. So now let's figure out what the hypotenuse should be. So again, we can set up a little Pythagorean theorem. We know that x squared plus x squared is equal to c squared. So that's our missing hypotenuse, would be this leg right here this time. So x squared plus x squared is 2x squared equals c squared. So to figure out what c is, we just square root. So I keep the square root of 2, and then x comes out. So my missing side is whatever x is times the square root of 2. So I'm sure this all looks familiar from geometry, that when you're doing that 45, 45, 90, the hypotenuse is just root 2 times whatever the legs are. So one more time, we can now find the sine, cosine, and tangent of this angle. So here we're just going to do this once because both the angles are 45 degrees. So we don't need to do 2 separate measurements for the 2 separate angles. So sine of 45 degrees. Sine of 45 degrees would be from, we can use this one as a reference, we would have this over this. So we would have x over x root 2. And the x's would cancel. So the way that we're going to see this normally, and I know I said up above that we don't need to rationalize, but it's normally better, we would rationalize this by multiplying by root 2 over root 2. So it's just a fancy 1, but what it ends up doing is it gets rid of our root in the denominator. So root 2 times root 2 is root 4, which is just 2. So it's better to see it in this form, which means that it's actually better to see this one as root 3 over 3. If we're going to rationalize this, we might as well rationalize that. All right, so same thing with 45. If we're looking at this one, we've got the adjacent side over the hypotenuse. So we'd actually get the exact same measurement. So we have 1 over root 2, which we now know is the same as root 2 over 2 if we rationalize that denominator. And finally, tangent. Tangent would be the opposite side over the adjacent side, and x over x, of course, just reduces down to 1. So those are our last values to use. So we're going to need to know those. They'll be memorized in the future, but for now, let's just have them written down.